This is Dustin Myers and Alex Nielsen for Chapter 9, Create the Foundations of Our Deployment Pipeline. One of the problems that we have in application creation is that we don't often test our code in production-like environments. Oftentimes, we test in production mode, where we deploy the code, we test it based on what the user says. And that is a problem because oftentimes when the code needs major repairs, the customer has to wait with broken code before we can send it to them. So the whole point of enabling an on-demand creation of dev, test, and production environments is to allow for automatic testing on demand in a production-like environment so that when our code goes out, it actually is functional, and we know that it's functional because we've thoroughly tested it in a production-like environment where we can be certain that the results will be the same, repeatable results in a real scenario. So as far as in the development portion of this, we need to run production-like environments on our own workstations. That way it's not we're not waiting for our turn to run it on a communal computer or something to that effect. We make sure that our code is functional up to the point that it's been given to us in our own environment. Also, this creates repeatability. If we test it and our partner next to us tests it each in our own environments on our own workstations, we can test it in various methods and prove that it is ready for the next step. In operations, we need to automate the environment creation process so that we can create environments that will allow us to thoroughly test code and make sure that it is fully operational. And in production, we need to produce well-tested and effective products and services. Using this method in the development and the operations should make production pretty simple because we should be delivering effectively tested, well-tested rather, products and services before they even roll to production. The next topic here is creating a single repository of truth for the entire system. The book refers to this as version control. And version control is, in essence, a way so that when we create versions of our code, we can roll back if something that we do doesn't work. So in order for a version control to be effective, we need to have virtually everything associated with our code in this file. We need, as is listed here on the screen, we need the app code and dependencies. We need the scripts that create the database schemas. We need the environment creation tools, files used to create containers, supporting automated tests, scripts for code, packaging, deployment, any other associated scripts, any project artifacts, cloud config files, and scripts or config info for the infrastructure in the version control file. From there, if something were to happen that our code would have a major meltdown in one version, using all of these, we can revert to a previous version, thus minimizing the need for downtime because we'll already have something that we know works in storage in case of failure. Ideally, in this scenario or this situation, with this method in place, we want to make our infrastructure easier to build than to repair. Repairing infrastructure can take a lot of time, effort, and cost, which can lead to downtime that may affect us, people down the stream, and customers who are waiting for the product or service to be rolled out. If we have a catastrophe or even just a simple problem, we should be able to revert, again, using the information provided in the previous slide, to a previous working version of our code and rebuild from there. We don't necessarily need to start from the ground up every time a catastrophe starts, especially if we are on the the thousandth iteration, if you will, of a piece of software. If we have a functioning backup that we can roll back to and start from there, then when something goes wrong, we can revert and keep trying until we get something that works better. Repairing can cause too many issues. And this also can happen with hardware. We should have hardware that is ready as well to make sure that if something like a server dies, we have a backup of that server's configs, files, things. We can re-implement a new version of it instead of trying to go back and repair it, which can often be a problem. In a production environment, we don't want to make any sort of manual changes. Everything should be as automatic or as automated as possible. It helps to remove a lot of human error and other factors that would potentially corrupt an entire project and just create a lot of problems for the value stream. Um, as was mentioned previously, when we make a problem in our system or service or program or whatever the case may be, um, we need to revert to an instance that does work and start from scratch rather than trying to go through and finding the problem. If it's something minor, that's not as big of a deal. But if we have a major problem, we need to go through and start from scratch. So that way we we have a system that helps us to move forward in a faster way. Um, we also need to make sure that we keep everything up to date. If we don't, we're going to have a problem with systems that are non-compatible. As one example, there's a variety of issues that can come by keeping things that are out of date. To modify our definition of development done to include running in production-like environments, there's a couple of points that we need to bring up in this section. The first thing is that we want to work in short iterative intervals, not the waterfall approach. The point of this is that we want to work on bits of the code at a time, work on a piece here and a piece there, and send those updates down the line instead of waiting until we have an entire rework of the entire system before we roll out the update. This this method will allow us to create more stable code as well as providing us with effective ways to keep things moving quicker down the value stream. The longer that we wait between release times, the worse things can get. For example, if a code has a lot of problems in it and it's in the customer's hands, let's say it's made it past production, if we wait a long time before we release an update that will allow it to function properly, the customer may get upset, may choose to go with somebody else, and could be bad for business for us. We want to make the changes necessary to make it functional and roll out as many updates in as short a time as possible to get them back up and working so that they're satisfied with us and so that we have a functional product in the process. We also want to make sure that quality analysis and the development and everybody all work together to all the time so that we make sure that the things that we do put out are working properly. And when not working properly, we can send them back and make sure that things are fully functional before sending them out. The final thing in this section is to decide what done actually means. In some of my coding instances that I've written, I've decided that done is when I finish writing the code, before I've even tested it, before I've done anything, and I deliver it only to find out that it doesn't work. Then I have to go back and troubleshoot, and it just causes a big problem. So the whole point of what it's teaching in this chapter is we want not only for our code to be complete, we want it to be built, we want it to be deployed, Yes, those are both attributes. But before we deploy it, we want to confirm that it runs in a production-like environment so we can prove that it's not going to crash and burn as soon as it rolls out to the consumers. We want to make sure that everything is fully functional and operational to the best of what we can do. There may still be minor bugs and things, and those can be resolved in later releases, but we want it to be as close to perfect as we can get it before we roll it out. Um, Redefining our way of calling code done can help us to again make sure that we're sending out quality products, but also that we're doing it in a timely manner and that we're not wasting time in between releases and things. It's just an effective way to move things forward. So just to wrap things up, we want to make sure that in development we run our own environments on our own workstations so that we can make sure that everything is repeatable. In operations, we want to automate the environment creation so that we can make sure that everybody is testing the code on a similar setup so that we can make sure that it's consistent across the board. In production, we want to make sure that we produce quality software and that everything is tested so that we can provide quality products. We want to create a single repository for truth as our version control, including as much about the project as we can possibly provide so that we can have something to roll back in case a catastrophe occurs or we need to revert to previous code. We need to make infrastructure easier to rebuild than repair to save ourselves time. We need to work in small iterative intervals so that we can make sure that we're providing updates quickly so that our end users are satisfied as well as others. And we need to make sure that when we say that a code is done, that it not only has been built and deployed, but it has also been run in a production-like environment so we can make sure that we're sending out quality products. And again, this has been Dustin Myers and Alex Nielsen with Chapter 9 of DevOps.